Kepler's third law says that T square upon dq for the planets is fixed. T is the sidereal period of the planets revolving the sun, and d is the distance along the semi-major axis. So, according to the Kepler's third law, T square upon d cube is fixed. The implication of Kepler's third law is the inferior planets will have a sidereal period less than 365.25, which is the sidereal period of Earth, and superior planets will have sidereal period more than 365.25. So it's interesting to note that Mercury, which is the planet closest to the Sun, goes round the Sun in 88 days, whereas Pluto, which is the furthest planet, which is also called dwarf planet sometimes, is going around the Sun in 248 years, right? Kepler's third law also helps you to find out the distance, estimate the distance from the Sun, distance of the planet from Sun, if we can track the sidereal period. How do we know the sidereal period? By the observation. Like there is a relationship between the sidereal period and synodic period, which we will learn a little later. But then if I know synodic period, I can find out sidereal period. If I know sidereal period, I can find out synodic period. And sidereal periods are related to the distance from Sun as per Kepler's third law, right? So in a way, we can say that Kepler's third law helps us to find out the distances of the planets from Sun. Like Mercury is 39% of the Earth-Sun distance. So if we consider the Earth-Sun distance as astronomical unit, Mercury is 0.39, Venus is 0.72, Earth is 1, Mars is 1.5, Jupiter is 5.2, Saturn is 9.5, Neptune 30.1, Uranus 19.2 and Pluto 39.5. These are the distances, right? Now T square upon d cube is fixed. If I know that the sidereal period of an inferior planet, say Venus, is 228 days, can I find out the distance of Venus from Sun? So here it is. If T square upon d cube is fixed, therefore d cube upon T square is also fixed, constant. So we may say that dv cube upon tv square is equal to de cube upon te square. So we can say therefore dv cube is equal to tv square upon te square multiplied by de cube. So we can say dv, taking the cube root of both the sides, dv is equal to de into tv square upon te square and the cube root, and therefore we can say that it is equal to de into tv upon te to the power 2 by 3, which is 0.667. If we put the values, distance of Earth from Sun, let's take it as 93 million miles, multiplied by TV, which is 228, TE, that is 365.25, to the power 0.667. If we put these values, that is 228 divided by 365.25 equal to the power 0.667 equal to multiplied by 93, that gives me 67.9 million miles. That is the distance of Venus from Sun, right? Now a little while ago, I told you that Venus has a maximum elongation limitation. Suppose this is the orbit of Venus. If I am looking at the Venus at Venus's maximum elongation, then the particular radius at which maximum elongation occurs, the angle between the radius and this tangent is 90 degrees. If I know this distance as 93 million miles, and if I know this distance as 67.9 million miles, I can find out this angle, which is the angle of maximum elongation. So what I do is, opposite upon hypotenuse is sine theta, I know, so 67.9 divided by 93 gives me a figure 0.73 something, inverse sine. That gives me 46.895. Approximately 47 degrees can be considered as the maximum elongation of Venus.